This video is math quiz number 3. In this video, I'm going to go ahead and read all the questions. I will give you the opportunity to pause the video and solve them on your own. And then at the end part of the video, I'm going to go ahead and work through the questions step by step, hopefully arriving at the correct answer. Suck if you watch this video and I don't know what I'm actually talking about, wouldn't it? If you have not already done so, I recommend finding out whether or not your testing agency provides you with a formula sheet. If they do, I recommend getting a copy and using it while practicing the math. I will leave links in the description to the ABC formula sheet and the one that I use, State of Florida. As for calculators, I recommend you get one of those cheap $2 solar powered calculators that can't do very much and practice using that, because believe it or not, when you take your exam, they're not going to let you use your cell phone and they're not going to let you use one of those scientific calculators because they think you might cheat. So again, get one of these little cheap solar powered calculators and try practicing the math with that. And just a quick note, I do not own any of the questions presented in this video. They were all sourced off the open internet. This is a study guide for educational purposes. If it helps you learn, that's great. Let's get into the questions. Question number 1. The pounds per day of chlorine used is 1,100 pounds, and the plant flow rate is 12.5 million gallons a day. What is the chlorine dosage in parts per million? 10.55 parts per million, 5.86 parts per million, 20 parts per million, or 8.56 parts per million. Question number 2. What is the detention time in a rectangular clarifier that is 225 feet long, 45 feet wide, and 17 feet deep when the flow is 3.7 million gallons a day? A. 13.7 hours, B. 8.4 hours, C. 0.3 hours, or D. 1.8 hours. Question number 3. Determine the volume of a circular tank with a conical bottom if the tank is 17 feet in diameter, the cylinder height is 26 feet, and the cone depth is 8 feet. A. 44,121 gallons, B. 48,646 gallons, C. 67,247 gallons, or D. 30,545 gallons. Question number 4. Raw water has a chlorine demand of 3.7 milligrams per liter. If 2.7 million gallons a day are being treated and a 1.2 milligram per liter residual is required, what must the chlorine feed rate be? A. 120 pounds a day, B. 151 pounds a day, C. 210 pounds a day, or D. 110 pounds per day. Question number 5. What is the flow if your plant uses 57 pounds of chlorine in 24 hours to achieve a dose of 2.3 milligrams per liter? A. 4.2 million gallons a day, B. 3.3 million gallons a day, C. 2.4 million gallons a day, or D. 3.0 million gallons a day. Alright, that concludes the part of the video where I read math questions. Now on to the part of the video where I solve math questions. By the way, the answer key is at the end of this video, so if you don't want to listen to me blather, skip to the end. Also, I will be leaving links to other types of questions that are similar whenever we're answering them in case you want more practice. Check them out. Alright, so question number 1 was, the pounds per day of chlorine used is 1,100 pounds, and the plant flow rate is 12.5 million gallons a day. What is the chlorine dosage in parts per million? With all word questions, I like to pull the known and unknowns out so I can keep track of them. So what we know is that you used 1,100 pounds. The flow was 12.5 million gallons a day, And what we're looking for is the chlorine dose in parts per million. To solve this, we're going to be using the Davidson pie chart shown here. And on the top, you have pounds per day of chemical feed 100% purity. In the bottom wedges, you have flow million gallons a day, dose milligrams per liter, and the standard of 8.34 pounds per gallon. And to solve for one of the pie wedges below the horizontal line, we're going to divide the two bottom pie wedges into the quantity of pounds above the horizontal line. So here we have that rewritten. Dosage, milligrams per liter, is equal to the feed rate, pounds per day, divided by the flow, million gallons a day, times 8.34 pounds per gallon. All our units of measurement match, so we can go ahead and plug it into our formula. So we have 1,100 pounds per day divided by 12.5 million gallons a day times 8.34 pounds per gallon. So let's solve the bottom math first. Multiply 12.5 times 8.34 and you get 104.25. So now we're going to divide 1,100 pounds by 104.25. And that gives you a dosage of 10.55 parts per million or milligrams per liter. They're interchangeable. Question 2 was, what is the detention time in a rectangular clarifier that is 225 feet long, 45 feet wide, and 17 feet deep when the flow is 3.7 million gallons a day? Start by pulling your known and unknowns out of the math question. So what we know is the length is 225 feet, the width is 45 feet, the depth is 17 feet, and the flow is 3.7 million gallons a day. What we're looking for is the detention time. The formula sheet provides detention time in days is equal to the tank volume in gallons divided by the flow rate gallons per day. So first, we're going to go ahead and solve for the volume, which for a rectangle is length times width times height. So you have 225 feet times 45 feet times 17 feet. You do your multiplication and you get 172,125 cubic feet. We're going to have to convert that to gallons. There are 7.48 gallons in a cubic foot. We're going to set that up so the cubic feet cancel out. So 172,125 cubic feet times 7.48 gallons per cubic foot. And your cubic foots and feetsies will cancel. You multiply. And your answer is 1,287,495 gallons. So we can plug that 1,287,495 gallons into our formula. Now we need the flow rate in gallons per day. Right now it's in million gallons a day, so we're going to have to convert that to gallons a day. There are 1 million gallons in an mg, so 3.73 million gallons a day times 1 million gallons over an mg. The mg's will cancel out and leave you with gallons per day. So do your multiplication and you get 3,730,000 gallons per day. Now we can plug that into our detention time formula. So you have your volume of 1,287,495 gallons. We're going to divide that by the flow of 3,730,000 gallons per day. So do your division. And our detention time in days is 0.3451729, but we're looking for hours. There are 24 hours in a day, so we're going to multiply that together. And your days will cancel out and leave you with hours. And the answer is 8.28 hours, and the closest answer is B, 8.4 hours. Question 3. Determine the volume of a circular tank with a conical bottom if the tank is 17 feet in diameter, the cylinder height is 26 feet, and the cone depth is 8 feet. As always, we're going to start by pulling our known and our unknown out of our word problem. What you know is the diameter is 17 feet, the cylinder height is 26 feet, and the cone depth is 8 feet. What we're looking for is the volume in gallons. So the volume of a conical tank is equal to the volume of the cone plus the volume of the cylinder. To find the volume of a cone is 1/3 times 0.785 times diameter squared times the height. And to find the volume of a cylinder when given diameter, it's 0.785 times diameter squared times height. And remember, when solving for volume in water treatment, everything must be in feet because our answer will get cubic feet. Our units of measurement are already in feet, so we can go ahead and plug these into our formula. So for the volume of the cone, you have 1/3 times 0.785 times the diameter squared, so 17 feet squared, times the depth of the cone, 8 feet. And for the volume of the cylinder, you have 0.785 times the diameter squared, 17 feet squared, times the depth of the cylinder, 26 feet. After you do the multiplication, the volume of a cone is 605 cubic feet, and the volume of the cylinder is 5,898.5 cubic feet. If you got different answers here, go back and make sure that you didn't switch your cylinder height and your cone depth in your formulas. So to get the volume of the conical tank, we add the 605 cubic feet of the cone and the 5,898.5 cubic feet of the cylinder. Add them together, and your total volume is 6,503.5 cubic feet. We need to convert this to gallons. There are 7.48 gallons in a cubic foot. So we have set this up so that cancels out. So 6,503.5 cubic feet times 7.48 gallons over a cubic foot. Your cubic feetsies and footsies will cancel out. And your answer is 48,646.18 gallons. And the closest answer would be B, 48,646 gallons. Question 4. Raw water has a chlorine demand of 3.7 milligrams per liter. If 2.7 million gallons a day are being treated and a 1.2 milligram per liter residual is required, what must the chlorine feed rate be? Let's start by pulling our known and our unknowns out of our word questions so we can keep track of them. What you know is the demand is 3.7 milligrams per liter, the residual is 1.2 milligrams per liter, the flow is 2.7 million gallons a day, and we're looking for the feed rate in pounds. Our unknown lets us know we're using a feed rate pounds per day formula, which is equal to dosage milligrams per liter times flow million gallons a day times the standard of 8.34 pounds per gallon. To find the chlorine dosage, we're going to take the chlorine demand milligrams per liter and add that to our desired chlorine residual milligrams per liter. So we're going to take the demand of 3.7 milligrams per liter plus the required residual of 1.2 milligrams per liter. We're going to add those two together, and that gives you a dose of 4.9 milligrams per liter. As everything is in the right units of measurement, we can plug it into our formula. So we have the dose of 4.9 milligrams per liter times the flow of 2.7 million gallons a day times the standard of 8.34 pounds per gallon. And that gives us a feed rate of 110.34 pounds per day. So that's going to be your closest answer is D, 110 pounds per day. Question 5. What is the flow if your plant uses 57 pounds of chlorine in 24 hours to achieve a dose of 2.3 milligrams per liter? Start by pulling your known and unknown variables out of your word problem. What you know is 57 pounds of chlorine were used, and the milligrams per liter is 2.3. What we're looking for is the flow. Anytime your known and unknowns are pounds, milligrams per liter, and flow, you're going to be using the Davidson pie chart. So here's the Davidson pie chart. Pounds per day chemical feed 100% purity divided by the flow million gallons a day, dose milligrams a liter, and 8.34 pounds per gallon, your bottom pie wedges. What we don't know is the flow. So to solve for one of the pie wedges below the horizontal line, we're going to divide the two known pie wedges into the quantity of pounds above the horizontal line. Here's that rewritten. Flow million gallons a day is equal to the feed rate pounds per day divided by the dose milligrams per liter times 8.34 pounds per gallon. Our units of measurement are already in the appropriate units, so we're going to plug everything into that formula. 57 pounds a day divided by the dose of 2.3 milligrams per liter times the standard 8.34 pounds per gallon. We're going to solve for the multiplication on the bottom first. You get 19.182. So we're going to do that divided into the 57 pounds. So 57 pounds a day divided by 19.182. And you get a flow of 2.97 million gallons a day. And our closest answer is going to be D, 3 million gallons a day. So here we have our answer key. You may have been taught if you don't know the answer, just guess C. Well, guess what? You'd have got all the questions wrong because there was no C's in this one. We had question number 1 was A, question number 2 was B, question 3 was B, question 4 was D, and question 5 was D. All right, so that was 5 random math questions for our little math quiz. I gave you the opportunity to work on them on your own, and then we worked on them together. So hopefully this video helped you practice some math. If it helps you learn, that's great. Thanks.